Hey, good morning, friends. In today's video, we are going to discuss what is composition of crisp relations. So, before moving to the actual topic, let me discuss some other important topics related to that one. And one of the very important topic related to composition of relations is Cartesian product of specific sets. So, you all know how we find the Cartesian product of any set. Basically, the Cartesian product that we call A cross B is set of all possible combination of items A and B. Okay, so if we have two sets, say A is one set, B is another set, we want to get Cartesian product, that is A cross B. So we will find all possible combination of the elements or items of A as well as B. For example, we have a set A. A is having elements A1, A2, A3. At the same time, we have another set B. B is having two elements B1 and B2. So all possible combinations will be A1, B1, A2, sorry, A1, B1, A1, B2, then using A2, A2, B1, A2, B2, using A3, A3, B1, and A3, B2. So these all will be the possible combinations of different items of set A and B, and this we call Cartesian product of two sets, right? So we are going to use the Cartesian products. Using Cartesian products, what we define is the relation between these two sets, and then using that relation, we will create two different relations and then find compositions of that one to create another relations, right? So let's see how are we going to display the relation in matrix formations. So again, we have two sets A and B. A is having value 1, 2, 3, 4. B is having value 3, 5, 7. The Cartesian product of that one will be 1, 3, 1, 5, 1, 7, 2, 3, 2, 5, 2, 7, 3, 3, 3, 5, 3, 7, and 4, 3, 4, 5, 4, 7. So these all will be the possible combinations that we can create it using set A and B. Okay, so how we are defining the relation? The definition of this relation is we want to find A and B where B is equals to A plus 1. This is the basic relation that we want to find it out, that all elements of this particular combination Cartesian product where B is equals to A plus 1. So let's see where B is equal to A plus 1. If we are talking about 1 and 3, this is position this. In this position, 1 and 3 is not following the relation B equal to A plus 1, because in this case, B is equals to A plus 2. So we are placing 0 in this case. If we check 1 and 5, again, the relation is not satisfied. B equal to A plus 1. 1 plus 7, it is not satisfied. So these all are 0. But when we are talking about 2 and 3, 3 is equals to 2 plus 1. So this relation satisfied. That's why we are having 1 here. Again, 0, 0, 0 in these places. With 4 and 5, you are seeing 5 is equals to 4 plus 1. So this relation satisfies that we are having 1 in this place. And again, 0 at 4, 7. Right. So in this way, we have formed a matrix of that relation that we have defined in this case. Okay. So we are going to use the relation for composition purpose. Composition basically means formation of, you will say, the third relation if you already have given two relations. Okay, so we have two relations, say R and S, and using that we can create some other relation. So utilization of composition is basically, suppose we are having A with B and B with C, and we want to find a relation between A and C. So if you already have a relation between A and B, two sets, if you are already having a relation between B and C, so using these two relation, what we can generate is, what we can compose is another relation that will be a relation between A and C. So for that, we use composition. There are various ways of finding composition. We are going to use max min composition for finding the basically output of this one. Max min is basically something very similar to, you call the product of matrices. So if you want to calculate the product of matrix, we do some specific formula for that one. And same way for calculating the min max composition of that one, what we are using, if you want to calculate T of A and C, so what we will get, max and then min of R A comma B comma S B comma C. So minimum of relations or relational value of this, as well as minimum of relational value of this, and then we find the maximum of those one. Okay, let's see it by an example. We have a set X that is having values 1, 3, 5. We have another set that is having the same value 1, 3, 5. We are giving a relation R by Y equal to X plus 2. We are giving another relation S by X is less than Y. So in that case, when we will calculate R, we will create a matrix of R, we will get it like this one, because 1 3 is the situation where we are following this condition y equal to x plus 2, and 3 5 is another position where we are getting the same value, we are uh, fulfilling this requirement. Same for s 1 3 1 5 3 5 are fulfilling this requirement. So in that case, this is the matrix formation that we will generate in this case for R, and for S this is another matrix formation that we are generating. So now we have two specific relation in matrix formation R and S, and we will apply min max max min composition in that one. Okay, so how we are going to do that? We are having max, okay, and we are having min of 0. We will take first row, we will take first column, okay, then first row, second column, then first row, third column, and then we will choose second row, first column, second row, second column, second row, third column of this one, and we will keep continuing till we are not reaching to the last one. So first row, first column, 0, min of 0 and 0 is 0, min of 1 and 0 is 0, min of 0 and 0 is 0. So finally we are getting back max of 0 0 0, okay, because in this case output will be 0, output will be 0, output will be 0, and max of 0 is again 0. Okay, if we'll do for second one, okay, same row and this second column, min of 0 and 1 is what? 0. Min of 1 and 0 is 0, min of 1 and 0 again is 0. So again we will get max of 0 0 0, and it is 0. And then for the third one, when 0 with 1, we will get what? In that case, what we are getting, minimum of this value is 0, then minimum of 1 and 1 is 1, then minimum of 0 and 0 is 0. Okay, so 0 1 0 1 1 1 0 0 0. So what we'll get here, max of 0 1 0, and max of 0 1 0 is definitely be 1. So we are having 1 here. So this is the only position where we are getting 1, and in rest cases we are getting the minimum value, that is 0. So finally the new composition or the new relation that is being generated in this case is this specific matrix, and this is how we are generating, we are creating, we are composing a new relation with the help of pre-existing relations. So this is the basic concept of composition, and in the upcoming video I'm going to discuss same concept compositions, but not for crisp relation. This time we will discuss fuzzy relation. So guys, till then please like and subscribe. Thank you very much.